characteristics, we'll talk about the initial phase and how to determine the initial phase if you have a horizontal simple pendulum. So if we have this pendulum, okay, in order to find the initial phase, which we call phi, we must pay attention to call the initial. So we must look at the initial condition. This is why I will trace here many examples. So we'll take the first example where we elongate the spring for at t equals to 0. We have x equals to xm, and then we release it. So we release it, this origin. So we'll do an oscillation. Now the question is to find phi, knowing that the solution is of the form x equal xm sine omega 0 t plus phi. And always the first thing we do is to put the initial conditions. So what are the initial conditions? First, I have at t equals to 0, x is equals to xm. This is the first thing. And the second thing, I have v is positive or negative. So we noted that if we release it, and this is the x-axis, so it will go in the negative direction. This means v is smaller than 0. We only need the sign of the velocity and not its value. So here we'll start with the initial condition. This means, so this is the first example. So at t equals to 0, we'll have x equal xm. Then this means by substitution, we'll get xm equal xm sine, and we're doing at t equals to 0, so we'll still have sine phi, which means that sine phi is equals to 1. Now, in order to find phi, so we use the calculator, and we'll get phi is equals to, here, pi over 2 radian. Now, for the sine, we have two solutions in math. If we get, for example, sine, if you have, for example, sine x is equals to a number and want to find x, we'll get that x is equals to alpha, or the second solution, x is equals to pi minus alpha. So here, the first solution is pi over 2, and the second solution will be equals phi 2. It's pi minus pi over 2. So it will become pi over 2 radian. Now, if you notice, it's not about two, we don't have two solutions. We have one solution, one common solution. So this is the accepted one. There's no two. So only one root. This means phi is equal to pi over 2 radian. This is the first example. Now, let's suppose we have now the second example. Let's suppose the spring was compressed and then we release it. So in this case, this is x, and this is the origin. This means in this case, I have at t equals to 0. So first step, we put the initial conditions. At t equals to 0, I have x equals to minus xm. And the speed is positive, since when I release it, it will go in the positive direction. So let's do now the substitution. In this solution, we'll get minus xm equal xm sine phi. So we simplify, and then we'll get sine phi is equals to minus 1. As solution, using the calculator, we'll get phi equal minus pi over 2. So this is the first solution. Now the second solution will become pi minus pi over 2 minus pi over 2, which is equals to 3 pi over 2. Now, are these two solutions? Also, it's only one solution. Since if we notice on the trigonometric circle, when I look on the trigonometric circle, when I say minus pi over 2, so this is the positive direction in the trigonometric circle. When I say minus pi over 2, this means it's here. This is minus pi over 2. So it's this point. And when I say 3 pi over 2, this means pi over 2, and pi over 2. So this is what you call from here to here. This is what I call also 3 pi over 2. So we notice that the same solution, we don't have two solutions. So this means as answer, I can say that phi equal minus pi over 2 radian, or I can say that phi equal 3 pi over 2, since they are the same solution. Now, third example, we'll take now that the mass was at origin, and then this is the x-axis, and then we launch the mass with a speed v, which is directed to the left. So in this case, I have at t equals to 0. So first step, we put the initial condition, x equals to 0. And I have v is negative. since directed in the negative direction. So let's write the solution xm sine omega 0 t plus phi. Now we'll substitute. This means 0 equal xm sine, so this is 0, so sine phi, which means that sine phi is equal to 0. So the solution here are phi 1 equal to 0, and the second one, phi 2 equal pi minus 0, which is equals to pi already. Now here, if you notice, we have two different solutions. So how do I know which one is the accepted? In order to know the accepted one, I must look at the second condition. So the first condition, our condition كانت x equals to 0. Now we notice that we have two solutions. So ما بيكفي وقف هون، بدي اطلع هلا بدي استعمل تاني condition. شو هي تاني condition؟ انه v لازم تكون negative at t equals to 0. This means first I must find v. We know that v equal x prime, which is equal, this means to xm omega 0 cosine omega 0 t plus phi. But v is smaller than 0, and this is at t equals to 0. So we'll substitute. This means v equal xm omega 0, and this is equals to 0, so it's cosine phi. Now, how do I know which one is the accepted? I substitute. First, I substitute the phi one. So we'll get by substitution, I'll get v equal xm omega 0 cosine 0. Now, cosine 0 is positive, and xm omega 0, this is positive. This means v is positive. Is it the condition given? No. The condition given is that v must be smaller than 0. So phi equals, this means phi equals to 0, it's rejected. It's not the solution. Let's try now the second one. So v equal xm omega 0 cosine, but now pi. Cosine pi is equal to -1, so it's negative. And here we have positive, so this means the answer of v will become plus and minus, so it become negative. And yes, this is the condition given in the exercise, so it's accepted, which means that the accepted one here, this is not the accepted one. The accepted one is phi equal pi radiant. So always, in order to find, if we have two solutions, in order to find the accepted one, we must look at the speed and its sign.